Hi Falcons. Today what I'm going to talk to you about is the atomic emission spectrum. The atomic emission spectrum is a property of atoms that we can see and observe based on the way that their electrons move in the various energy levels. So what we have here is an energy source, and then here what I have is a gas tube. This gas tube, for example, contains hydrogen gas. So an electrical current is going to travel through these electrodes, so it's going to be passed through there and through the gas that's in that sample, energizing it. What you're then going to observe is the electrons in those gaseous atoms are going to jump to an excited state. That won't show you anything. But what you will see is when those excited electrons then fall back to their ground state, they're going to emit a photon. And that photon is going to be of a specific amount of energy corresponding to the energy difference between those levels. What we've learned is that energy photon is going to have a very specific wavelength and a very specific frequency. Different wavelengths obviously are going to transmit different colors. So I'm going to show you this one now. This is hydrogen gas, and if you were to look at this through a spectroscope, you would see what we're trying to show you now, which is what was referred to as a bright line spectrum. You won't see a rainbow, you'll see a series of bright lines corresponding to different wavelengths, aka different frequencies, which correspond to different energies, differences in energies between those levels of photons that are emitted as electrons move from these excited states down to these ground states. If we were in class, we would be observing this through a piece of equipment like this called a spectroscope. This spectroscope has gratings in it similar to what you observed on the video, but would also then have markings in here that would tell you the wavelength based on the amount that that light was bent. The higher the wavelength, the more the light would bend. And you would see then a particular pattern that would be specific and actually be able to allow you to identify hydrogen gas. I'm now going to show you several other characteristic gases and show you that each one of them has its own unique color spectrum. The next one that I'm going to show you is nitrogen. And you can see that it has a different color spectrum than the hydrogen did. That's because, again, it's going to have a different number of electrons, and the differences in the energies between those levels that are going to be emitted are going to vary from atom to atom. This is incredibly important. It can allow us to identify elements that are in various compounds or in deep space and things like that, places that we can't get to based on these signatures of light that they emit. Another one that I'm going to show you now is argon gas. And just to show you again, another unique and different signature of light. Each gas, each element would have its own unique signature of bright lines based on the wavelengths of those photons that are emitted as those excited state electrons return to the ground state. The final one I'm going to show you is probably the most characteristic or well-known, because we see it in signs at restaurants and grocery stores and things like that, which is neon gas. It's an especially bright emitter of these wavelengths so that we can see some of which fall in the visible spectrum. So this is the atomic emission spectrum. Thanks, Falcons.